Hello guys, welcome back to Hot News Studio and welcome back to our segment Science and Technology. Today we are going to tell you about the winners of Nobel Prize in Physics. The Nobel Prize in Physics was awarded to Perry Agostini, Ferenc Krauss and Anne Alhulier on Tuesday for techniques that illuminate the subatomic realm of electrons, providing a new perspective into a previously unexplored domain. Electrons move at a whopping 43 miles a second. This speed has long made them impossible to study. The new experimental technique created by the three scientists laureates used short light pulses to capture an electron's movement at a single moment in time. Think of a rotating fan at its highest speed. Each blade is blurred. But if you point a strobe light at the fan, every flash will illuminate a frozen moment in time. As the flashes get shorter, more information about the fan is received. To study the movements of electrons, the scientists had to use pulses of light that last only on the scale of attosecond. An attosecond is 1 quintillionth of a second. The number of attoseconds in a single second is the same as the number of all the seconds that have elapsed since the universe burst into existence. That is 13.8 billion years ago, according to the Royal Swedish Academy of Sciences, which awards the Nobel Prize. Eva Olsson, the chair of Nobel Committee for Physics, said at the news conference on Tuesday that attosecond science allows us to address fundamental questions by measuring the relative positions of electrons in an atom. Who are the winners? Perry Agostini, 82, is an emeritus professor at Ohio State University. He was educated in France. Ferenc Krauss, 61, is a director at the Max Planck Institute of Quantum Optics in Germany and a professor of experimental physics at Ludwig Maximilian University of Munich. He was born in Hungary. Anne Alhulier, 65, is a professor at Lund University in Sweden. She was born in Paris. Dr. Alhulier is the 5th woman to win the prize in physics. The last woman to be recognized in the category was Andrea Ghez, an astrophysicist, in 2020. Why did the committee say they were receiving the prize? In 1987, Dr. Alhulier laid the groundwork for the investigation at electron level by studying the effects of shining an intense laser through noble gases, odorless, colorless, single-atom gases with low chemical reactivity. She discovered that the laser energized the gas, causing it to emit light at special frequencies. Light is an electromagnetic wave characterized by crusts and dips whose distances relate to its frequency. These waves interact with each other as they travel, becoming more intense when the crust meets one another and cancelling each other out when a crust coincides with a dip. Dr. Alhulier's work revealed the potential for these waves to line up just right so as to create short pulses of light that could be used to study electrons. But scientists were not sure how to combine these waves or measure such short pulses until 2001, when Dr. Agostini successfully demonstrated a method to produce a series of light pulses lasting 250 attoseconds. Independently, Dr. Krauss used a different technique to generate a single pulse of light lasting 650 attoseconds. Subsequent advances have made it possible to achieve pulses as short as a few dozen attoseconds today. Scientists can use this subatomic strobe light to take a snapshot of the inner working of the atoms. The effect won't produce actual images but will reveal information about the relative positions of electrons around the atom or within the molecule, and how much time it takes to pull them away from the nucleus they are bound to. Attosecond physics will allow scientists to measure the timings of electrons being released from material when light shines on it. Albert Einstein received the 1921 Nobel Prize in Physics for establishing the theory of this phenomenon known as the photoelectric effect. Assessing the ultra-fast world of electron motion may also lead to advances in the circuitry, drug design, and the material used for batteries, as well as non-invasive diagnostic tools in medicine. Louis de Moreau, a physicist at Ohio State University, described Dr. Alhulier's work as a suite of elegant experiments and superb theory. that laid the foundation for the potential of electron motion capture. Dr. Agostini and Dr. Krauss then followed the challenging prescription to make this decades-long dream a revolutionary reality, he said. The discovery sheds light on physical systems that occur at short time scale and provide physicists with a new tool to tame the microscopic world. Ignacio Cirac, a theoretical physicist at the Max Planck Institute of Quantum Optics and a colleague of Dr. Krauss, wrote in an email. These stroboscopic images of electrons like of dancers in a club have sparked the creativity of researchers around the world, according to Jean-Michel Ross, the director of Max Planck Institute for the Physics of Complex Systems. Physics throughout history has advanced every time we make a quantum leap in precision, Dr. De Muro said. In this case, the quantum leap was jumped into the attosecond time domain. What did the laureate say about winning the prize? Dr. L. Hulier was in the middle of a break during a class she was teaching when her phone rang, and according to the Nobel Foundation, she took the call in a corner and learned the news. "I'm so happy to get this prize," she said. "It's incredible." The new laureate then went back to her teaching, though the last half hour of my lecture was a bit difficult to do, Dr. L. Hulier said during the announcement ceremony. "As you know, there are not so many women that get this prize," she added, "so it's very, very special." You can see the tweet of the Nobel Prize on your screen. A round of applause. Students and colleagues at Lunch University came together to recognize newly named physics laureate Anne L. Hulier. Drop in the comments to congratulate our new Nobel Prize laureate. Dr. Krauss was preparing physics lectures at his home when he got the call. "I just wasn't sure whether I'm dreaming or whether it's reality," he said. His first thoughts were with the many friends and collaborators who have directly or indirectly contributed to this, he said. The Nobel Foundation was unable to reach Pierre Agostini, who was in Paris at the time of announcement. Dr. Agostini found out about the win from his daughter, who called to ask if the news was true. "I thought it was some kind of mistake, but it was not," he said, adding that his first inclination was to hide away from the newfound fame. "Why they choose to award this kind of research now is a sort of mystery," said Dr. Agostini, who ran the experiments lending to the prize over 20 years ago. But he added, it's better late than never. So that's it for today. Thanks for watching this video. If you like this video, please do like, share and subscribe our channel. We will meet again in the next video. Thank you.